Today we will show how to properly and safely operate the UZ100 Bold. The UZ100 Bold is a machine with automatic feed using chip machining. Its main advantage is its ability to process not only plain carbon steel, but also stainless steel and other harder steels such as hardox or duplex. A major advantage is not only the bevel, but also J-bevel, cladding removal, or tapering. The maximum bevel width is up to 100 millimeters. The angle setting ranges from 0 degrees to 90 degrees. The thickness of material that we are able to load into the machine is up to 100 millimeters. The adjustable control panel is divided into two clearly defined main sections: the operation of the milling head, including turning it on and off, the adjustment of the tool's rotational speed, and the control of the feed rate, along with on and off switching, reverse motion, and the regulation of cutting speed. In the central portion of the control panel, you will find a button for automatic workpiece clamping. These are the two clamp and release control buttons. The machine possesses a sophisticated mechanism for thoroughly leveling irregularities in the floor or in the machined material. Let's set up the machine for a specific job. On material with a thickness of 25 millimeters, we want to achieve a root face of 2 millimeters and a chamfer height of 23 millimeters at a 45-degree angle. First of all, we must always set the chamfer angle. First, we loosen the locking screws, which are located on both sides of the machine. Using the ratchet wrench, which is part of the equipment, we set the required chamfer angle, in this case 45 degrees. We subtract the values shown on the installed scale precisely. We will once again properly and securely tighten the securing screws. The next step is to precisely set the chamfer size. But first of all, we must establish the so-called 0 point. That means the exact place where the milling head touches the edge of the material. To prevent any unwanted collision between the milling head and the workpiece during the 0 point setting process, we must move the tool sufficiently away from the active working zone. Please release the lever that secures the tool, which is located on the bottom side of the spindle housing, and, with the aid of a correctly sized ratchet wrench, slowly and carefully move the milling cutter away far enough to clear the area and provide safe working access during setup. Should it be necessary, we can adjust the machine's working height relative to the material being machined by turning the control wheel located on the side of the machine. This can be performed either manually or with a screwdriver. To precisely locate point 0, place the machine anywhere on the machined material so that the guide rulers remain in contact with the edge of the workpieces along their entire length. Now we will securely fix the machine with an automatic clamping system. We will enable securing of the milling cutter, start the main motor, and move with the cutter toward the material until we hear the typical scraping sound against the material. To calculate the cutting plan, we will use the portable beveling solver calculator. First, we will select the appropriate machine. In the value section, we will choose the bevel angle and removal amount. After entering all the values and pressing the OK button, a table will clearly appear showing how many steps the requested operation will take and which values we set in the machine. Based on the calculation, we understand that the required bevel will be carried out in 4 steps. In each step, we will add 5 millimeters, and for the final cut, 2 millimeters. First, we loosen the locking lever, which is located on the rear side of the spindle, and on the scale, we will add the first 5 millimeters from the current 0 point. Attention! 1 division on the scale corresponds to 2 millimeters of the milling cutter's travel. Please make sure to carefully secure the spindle lever. As the very last step before starting the machining, we set up the machine so that the milling head is not in contact with the material, while at the same time, the vertical plate stays parallel to the edge of the material. We clamp the machine to the material using the clamp button on the control panel. Now we come to the point of establishing the cutting conditions. This means configuring the tool speed and the feed rate. For ordinary steel, we recommend setting the speeds at about 800 to 1000 per minute. It always depends on the condition of the cutting inserts, the strength of the workpiece material, and the size of the chamfer. The feed rate should be lower during the entry phase. During the sheet exit, we'll slow speed once more. The initial cut has already been completed. The second and every subsequent one is set in the same manner. If we have set everything up correctly, the appearance of the chamfer at the start, at the middle, and at the end is exactly the same under these conditions for all cases. And now, with regard to routine maintenance of the machine, let's discuss it briefly for reliable operation. In the lower part, there is a sturdy steel bath into which chips from the machining freely fall. Not all chips, however, end up staying in this bath. Excess chips which remain within the machine space must be continually removed using the attached chip hook or by using compressed air for removal. In conclusion, we will demonstrate how to disassemble the cutting tool to replace or rotate its own cutting discs. And that is all for today. In the upcoming videos, we'll show how to perform applications with this UZ100 Bold machine, such as J-bevel, facing, or cladding removal. Bye!